Okay, we're going to kick off probability now with tree diagrams. Now, look at these trees here. These are the mighty redwood trees in California. They're some of the tallest trees in the world. Check them out, they're great. Okay, all good probability questions are only ever to do with balls and socks. Okay, so look at this. There's always a use for a big red ball. All right, let's put him there. Right, let's start. Okay, so we are going to take 2 balls out of this bag without replacement. What I mean is we're going to take the first ball, hold on to it, and then take the second ball. Okay, so the first thing that can happen is I either out of the bag take a blue ball or I take a red ball, and that's called my first pick. I'm hoping you're thinking, yeah, I've done all this before. So what's the probability that I take a blue? It's 3 out of 8, and a red, it's 5 out of 8, and the probabilities go on the stems. Okay, so if I've taken a blue, the next thing I can do is take another blue, or I can take a red, or I can take a blue, or I can take a red. And this is my second pick. Pick, that says, pick. Okay, and the blue, now if you think about it, we've held on to the first ball, so now all of these are out of 7. Okay, so those are all out of 7. Now if I've taken a blue one first, there aren't 3 blues left anymore, there are 2, but there are still 5 reds. And what I'm going to do is just double check that those 2 add up to 1, which they do. All right, pairs of them should add up to 1. If I've taken a red first, there were 5 reds, so now there are 4, and there are still 3 blues, and yep, they still add up to 1, so that's fine. Okay, let's answer my question. What's the probability they are both blue? Right, both blue is this route along here, so I'm going to write a blue, and when we come to do some hard probability, you'll see why I'm writing that out later. So blue and a blue. Now, this is really important. Everyone goes, am I timesing or am I adding? Am I timesing or am I adding? Right, can you see this? This is a fantastic tree. You can Google this. This is called the Pythagoras tree. It comes from fractals. Have a look at it. It's amazing. It's actually a mathematical tree. We times... Can you see the word times? The pen, come back. We times along the stems. All right, so we times along the stems of the tree. And the word times and stems is virtually the same letters, except obviously times has got an I in it. So we are going to times this one and this one together. We are timesing along the stems. Okay, 3/8 times 2/7 is 6, and 7/8 7 times 8 is 56, so that's my answer. What's the probability there is one of each colour? Okay, one of each colour is going to be this route, blue and red, so the probability of blue and red. And where else do we get one of each colour? This route, so the probability of red and blue. Let's just move my tree out the way. Tree, move out the way. Okay, so blue and red, we're going to do 3/8 times 5/7. So 3 times 5 is 15, 7/8 are 56, and red and blue is 5/8 times 3/7. So again, that's 15 over 56. Now, I do not mind if I get this route or this route. So I don't mind this one, or this one. And what do we do when it's an or? We add them together. So we add going down. So if we add 15, come back pen. So if we add 15 and the 56 plus 15 out of, why have I written 57 there? 56, we will get 30 out of 56 as our answer. Okay, do you remember all that? Brilliant. Here's your question. When I say pick 2 without replacement, I mean pick one, hold on to it, then pick the other. Look at this. This is socks, isn't it? Do you remember making these as a kid? Look at that. Girls, do you remember those white socks you used to wear at school? They had a name, didn't they? I can't remember them. Anyway, fantastic. If you got a bit of time, you could knock some of them up. I'll pop the answers up in a sec, okay? Here come the answers. We want 2 of the same colour. So that's that one or that one, okay? That one or that one. So it's going to be 20 out of 56, add 6 out of... Why do I keep saying 7/8 of 57? out of 56, which gives me 26 out of 56. Okay, so the next one we're wanting at least one red. So at least one red could be this one. That's at least one red. So 15 out of 56. Or could be this one. This is at least one red. So 15 out of 56. And of course, at least one red could be this one. We could have two reds. So plus 6 out of 56. And that gives me 36 out of 56. And a quicker way to do it would be, instead of working out those three and adding those three up, we could have just found the one that we didn't want, which is this one up here, and taken it away from 1. All right, so 56 out of 56 minus 20 out of 56 gives me the same answer.